Welcome to 3.3. In this video, we will learn how to find the molecular formula if we're given some additional information. First, let's complete this review problem. The bacterial fermentation of grain to produce ethanol forms a gas with a percent composition of 27.29% carbon and 72.71% oxygen. What is the empirical formula for this gas? Pause to work this out before continuing to see the answer. If we assume we have a 100-gram sample, then we have 27.29 grams of carbon and 72.71 grams of oxygen. Convert both of these masses to moles using the molar masses of each element. Then we divide both the mole amounts by the smallest mole amount, which gives us the mole ratios. The empirical formula is CO2, and this is what we learned in the last video. Now for this example, this happens to also be the molecular or true formula. We know that carbon dioxide is a product of grain fermentation. However, the empirical formula is just the simplest whole number ratio of the molecular formula, so often it is not the same as the molecular formula. Let's try the next example problem. A compound contains 74.02% carbon, 8.710% hydrogen, and 17.27% nitrogen. Find the empirical formula of this compound. First, we need to assume a 100-gram sample. Pause and work out this problem, finding just the empirical formula to start with. The empirical formula is C5H7N. Now, for the next step, in order to find the molecular or true formula, we need to be given the molar mass of the true compound, which is what this says. If the molar mass of the true compound is 162.28 grams per mole, what is the molecular formula? Since we know that empirical formula is the simplest whole number ratio of the molecular formula, we know that the molecular or true formula could either be this exact empirical formula that we found in the first part, or exactly double C10H14N2, or exactly triple C15H21N3, or exactly quadruple, and so forth. We need to find the mass of this empirical formula so then we can compare to the molecular formula mass that was given here. So we need to find the mass of the empirical formula. Take your calculator and periodic table and add the mass of 5 carbons plus 7 hydrogens and 1 nitrogen. If you do that, we get 81.116 grams per mole. Now we can compare, or in fact divide, the masses. So let's take our 162.28 grams per mole and divide it by the 81.116. When you do this, you get 2.00059 plus some more digits. This is very, very, very close to a whole number of 2. This means because the molecular mass is twice the mass of the empirical formula, we know we need to double the subscripts on the empirical formula. C10H14N2. This is the molecular or true formula. And there's our answers. I enjoy including funny pictures into my lessons. This is problem 11 on the problem set 3.3. First, we need to find the empirical formula. If we assume we have a 100-gram sample, then we have, from this 26.7% carbon, we know we'd have 26.7 grams of carbon. 2.2% hydrogen becomes 2.2 grams of hydrogen, and 71.1% oxygen becomes 71.1 gram of oxygen. Make sure that your percentages equal 100, so that when you have a 100-gram sample, all of your gram amounts equal 100. First step is to convert mass to moles using their respective molar masses. Pause and work this out before seeing the answer. We have now converted our masses to moles of each element. And now divide it by the smallest of these three to find the subscripts for the empirical formula. We always have to find the empirical formula first before we can find the molecular formula using the molecular formula's molar mass. The empirical formula is CHO2. Now we need to find the mass of this empirical formula so we can compare it to the mass that was given for the molecular or true formula. If you add up 1 carbon plus 1 hydrogen plus 2 oxygens, we get 45 grams per mole. Here's your carbon plus your hydrogen plus your 2 oxygens. The ratio of the molecular weight, the 90, to the empirical weight of 45 is a 2 to 1, which means we know that the molecular formula is twice the mass as the empirical formula. Therefore, we need to double each of the subscripts in the empirical formula to get the molecular formula, which ends up being C2H2O4. Now you can complete all the practice problems from 3.1 through 3.3.